All right. Thank you very much, guys. And anyway, it's the first day. We're doing our lesson online with you as the NCUK students. All right. We are going to look at the new chapter, which is electric field. But before that, I want us to recap and just to see what we already know. Like for instance, in maths, you're always dealing with the signs, negative and positive. Those signs, they are actually called charges in physics. So therefore, I have a positive charge. As you can see here, this is my positive charge. And then here I have what? A negative charge. Can you see that? All right. Now then, what happens when you bring a positive charge to another positive charge? They repel each other. Even negative and negative, they also repel each other. So we say that like charges, they actually repel each other. But the unlike charges themselves, they attract each other. Now, the force that exists between the negative and negative, we call it a repulsive force. All right? A repulsive force. All right. And then a negative and positive, because they are unlike charges themselves, they attract each other. Therefore, the force is called what? An attractive what? Force. Do not forget that. All right. All right. Now, without wasting time, guys, what's wrong now? What's wrong now? Is everything okay? Yes. Okay, very importantly, let us just also recap as to what's a symbol of a charge. We know that a symbol of a charge is actually a capital letter Q or small letter q. That's the symbol of a charge. All right? And another thing, we know that the charge is actually measured in what? In coulombs, which is a capital letter what? A C. As you can see, it's a capital letter what? C. Now, the magnitude, very importantly, and I know you know this, but then please, bear in mind that we always using the constants now and then. Right? Now, the magnitude of the charge on an electron is 1.6 exponent minus 19 coulomb. This is what? The magnitude of a charge on an electron. It's a very same thing with what? With the proton. The magnitude of a charge on a proton is positive, because this one is what? Is negative. Negative 1.6 exponent minus 19 coulomb. But if it is a proton, it becomes positive instead of what? Of negative here. Do you understand? Yes. Okay, very good then. That's sometimes they call it an elemental charge. Sorry? The screen, we cannot see the screen completely. Okay, fine. I'll try to make it easy for you. Can you see it now? Boys, can you see it? Yes, yes. Is it better now? Okay, thank you very much, boys. Thank you very much. All right. Now then, let's see that. Sorry? Yes, because negative for is a charge, and also what? A positive for what? Negative for electron and a positive for what? For a proton. Okay, fine. Now, a question is, what is around the charge? That's the question. Now, around the charge, there is what we call an electric field. There is what we call what? An electric field. What is an electric field? Now, before that, as you can see, this is positive and this is negative, right? They are separate. They are separate from each other. Now, this is how the electric field is arranged. So this is a line. This is what the line. And this is line for what? For a negative test, a negative point charge, not test. Alright? So, if you look at these lines, we call them what? Electric field lines. Sometimes they call them what? Electric force lines. Alright? Yes, electric force lines. Alright then, if you look here, this is positive, this is negative. These lines, the directions, the arrows that you see, they're actually telling you the path of a positive charge if it is in the field of that charge. I will repeat. These directions, the arrows that you see here, they are actually telling us what would happen if we place a positive charge in that field. Like for instance, if I place a positive charge here, where it will go?
To the opposite direction of the positive.
Yes, because it is what? Yes, it is being repelled. So therefore it's going to move away. This is the reason then what we have the arrow pointing away from the positive charge. But then let us put it here then. Let us put a positive charge here. What would happen here? What would happen here, boys? Hello? They will attract each other. They will attract each other. So therefore, that's why then the sign for positive charge, it goes towards. Do you understand? The arrow, it goes towards, because if you place a positive charge, it will just go straight to what? It will be attracted by what? By the negative charge. Do you understand?
Yes.
All right. So now the question is, how can we define the electric field? Electric field, we say that it is a region. It is a region in space. So a region in space around the charge, where a positive charge will experience what? A force. We see this. Okay, fine. I think I forgot something. Will experience a force here. There must be a force. Will experience a force. Oh my God. Anyway, there is a force here. Will experience a force when placed in the field. Alright, don't forget here, I'm going to send this note to you boys. So here there is a force. I'm going to save this and send it to you, alright? Boys.
We are listening, you visit us.
Who's here then? It's only you and Chukran, is it?
No, Chukran, me, Ali, and Buga, also comes listening us.
Okay, fine. Al-Nur is not here.
No, Al-Nur is not.
Okay. Okay, guys. Do not forget then how to draw for negative and positive. Alright? We call them electric field pattern, but I'm going to talk about that later, whereby I'm looking at all the the possible electric field patterns. Alright. Now then, if you look here.
Teacher.
Yeah?
What does positive Q mean near the fields?
Say it again?
Positive Q near the fields. Positive and negative fields.
Oh, you mean the smallest one, this one?
Like on the top. On the bottom of the field, you drew it. Yes, that one.
You mean this? This?
Wait. It's like...
Hello?
Yeah, this one. Positive Q. Under it.
Oh, you mean this one?
Yes.
Oh, say, I was explaining to you this direction. This direction. Can you see this direction? This direction, they're telling you the direction of a positive charge in the field or next to this charge. So if I place this here, where it will go? It will go away. Why it is going away? It's because of this one is positive, so therefore it is being repelled. So this direction, it actually tells you the path that a positive charge would take if it is released in this position. Do you understand? Yeah, even look at this. Look at this smallest one. This one, what would happen? It's going to go towards. Can you see this sign? It's going toward. So this positive charge will actually go to this one because it is being attracted. But do you understand what I'm saying? Alright. So actually, let me just erase it. I just drew it because I was explaining. So I can just erase this. So now you must always know how to draw a positive and negative. Okay? Electric field pattern. Alright. Now then, let us see what can we do then now. Alright. Now, if you look at here, these are electric field patterns. How to draw electric field patterns? Can you see this is positive? This one is positive. Can you see positive? You can just even draw like a cross, but then make sure that they do not pass through the circle. All right? Can you see this? Can you see this? A perpendicular from the surface.
Yes.
Okay? That's how you draw it. But then the direction, can you see the direction? This is our direction. Okay? This is for positive charge. And then this one for negative charge, it goes towards. As you can see, it goes towards. Alright? So if you place a positive charge here, it's going to go straight here because it's going to be attracted. But if you place a positive charge here, it's going to go away. That's why the arrow is pointing downwards or away from the charge. Okay? But just look at this. Just look at this. What if you have two positive charges or two negative charges? Can you see this? They repel each other. This one, it shows that the electric field, they are going this way. Can you see this way? This way, this way, this way, this way. What does it mean? It means that there is no interaction between the two charges. So therefore they repel each other. Do you understand what I'm saying? Boys, yeah, they repel. Even if it is negative, it's still the same thing. So it will repel each other. But if it is negative, it's going to point towards. The arrows were going to point towards. Do you understand what I'm saying? Boys. Okay, alright. Now, what about this then? What about this? This one is what? There are two positive and negative charges. So therefore, opposite charges. Now, this is negative and this is positive. So because this is negative, this is positive, it means that my arrow is going to go from positive to negative. Because this is negative, so towards, like this. It will be like this. Alright? And then here, because it's negative, it's going to be like towards, and this way, this way, this way. And then from there, here, it's positive, so away, 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 away. Can you see this? Very good, boys. Don't forget, here they interact. That's why the lines, the electric field lines, they join each other. Okay? The lines of electric field for both negative and positive charges, they join each other. So therefore, you draw it this way. Firstly, this line is actually a straight line in the center. It's a straight line. And then the other ones, they cave. They cave. The other ones, they cave. They cave. Alright. The other ones, they cave. As you can see, they cave like this. Now, if you look here, the electric field lines, They are very close to each other, and there are so many compared to this one. We say here, electric field is stronger. Electric field is strong. Sorry?
No, I think teacher, I said to you, something happened to my Skype.
Okay, fine. Anyway, I'm saying here, the electric field, they are closer to each other at this point. So therefore, electric field here is very strong. But here, it's further away from each other and they are very small. So weak. Electric field is weak. Okay, electric field is weak here, alright. Now, what about if we make, let's say we take two parallel plates. We take what? Two parallel plates. What would happen then in this case? Right. I don't know why it's not... Where it's stronger, where what? Where the electric field is closer to each other. And it's so many. You can see.
Between the particles.
Say it again.
Between the particles.
No, not between the not between the particles. In one side, if you look at, I just wanna. Okay, fine. I just need this. Okay, if you look at this, Mr. Bugard, if you look at this one, can you see here? There are so many electric fields here compared to this one. Electric field lines. So here it means that at this point only, this point, the electric field is very strong. But here it's weaker because they are far away from each other and they are few. But here they are closer to each other. So therefore it's very strong here, alright? Alright, then fantastic then boy. Right. Something that I want to do here.